Now that we have our parallel circuit drawn and we have our text in our circuit, now we need to export this to our Excel file. What I'd like for you to do is, like we did before, just click on the whole thing here. So you notice, let's explain this. So if you notice, if you click and drag, if you hold, your cursor kind of lets you pan to choose what you want to select. But if you just click and then drag to the other side, it makes a box so that you can highlight the things that are in the box. If you go from the top to the bottom, it only selects the items that are completely in the box. But let's escape and let's go from the bottom to the top. You notice that it selects items that the box just touches. So if the box just touches those, that text, it becomes highlighted. It does not have to touch the whole thing. It does not have, boxes don't have to include the whole thing. It just has to touch a part of that drawing, and then it will select it. So if we go from the bottom to the top, we can select all of our programs, and you notice that everything is selected. So then we're just going to copy. We can do a Control C, or we can come up here to File and hit Copy. Either way, that will copy our drawing on our clipboard of our computer. And I have already had Excel open, but you can open Excel. I just opened mine already to save some time. But you open Excel and just click on a cell. It does, at this point, it doesn't matter where it's located. We're going to have to readjust this anyway. So just click on a cell, and then we're going to right click, and then we're going to do a special paste. You cannot just paste it into the circuit. It won't be formatted correctly. So we're going to paste this as a picture, and that way we can edit the size of our picture. So select picture and then hit OK, and then our drawing will be in our Excel file. Now we need to format our picture because this is way too big. We don't want that to take up that much space. So we're going to hit picture format, and then we're going to crop. So we want to crop our picture to just a little bigger than it actually is. So we'll come over and maybe half a box there, and then you have to scroll over on your screen to get the other side in. And we'll bring the other side up. You get the little triangle, and it only moves that corner. You have to arrow over here to get the other side. We'll bring this corner in to where it's just barely bigger than our drawings. And that will be the size that we want for our Excel file. So if we click off of that, and that will make our picture the same size. But now you notice it is not centered or not where we want it on the drawing. And you notice that if I click on it, I get the little, I can either make it bigger or larger, or if I get like the crosshairs, I can click on it and drag it. And we will move it over to where it's closer to the corner of our drawing. We may have to play with this a little bit, but I want to leave a little space at the top. So this is 1 and A. So this is top of our drawing. I would like to do like we did with our series circuit. I would like to put a little border around it. So I would like to leave the column A open, and I'll put a border around the top and a border around this side. This time I would like to make our border a little closer to the same size. So I'm going to make this a little bigger. I'm going to come down to about 16 here on the height. Then we're going to move this over to about 4 on the width of our column. So that makes these a little closer to the same size. And then we're going to come over here to column N, and we're going to do it the same way. We're going to make it. Okay, I've already went ahead and made our table down here. I'm going to let you make your table. We're just going to go over 5 and down 5. I did add a little more to this cell. I made it around 10 and a half, so it would have enough room for our resistance in there. So these cells will be where we input our data from our resistance. This cell will be where we do our calculations from. So to do our calculations of total resistance, we're going to hit equals so that Excel will know we are doing a formula. And the total resistance is 1 divided by, and we have to use our parentheses, and then we're going to go 1 divided by R1, which will, if you just click on this box, it will put that in there for us. Then we go plus 1 divided by R2, and again we can just click on the box and it puts that box coordinates in for us, and plus 1 divided by our R3. Now since we started with the parentheses, we have to put a parentheses at the end to close our formula. And then we hit enter, and then this will automatically calculate our total resistance of this parallel circuit. Now this has like an error here because we don't have any values in it. Now whenever we're finished, I want you to turn in your Excel file with these data in your boxes. I am now just going to put in a number just to show how this is working. So I'm going to put in 5,000, 5,000, and 5,000. And then that will be our total resistance of 1.66K. This is not displayed in engineering notation. So if we remember from our last video, I want these columns here to have engineering notation. We're not going to have engineering notation for our voltages, but we are going to have our engineering notation down here. So if you hit the control button on your keyboard and highlight these, it will allow these cells to be formatted with these cells, and these cells will not be formatted. So we click those and we come up here to our number format like we did previously. Go to custom. We're going to remove our general number format, and we're going to put in our 2 pound signs or hashtags. We're going to put a 0.00, so we will have 2 spots past the decimal point. We're going to put a capital E plus a 0 to show us our exponent. And that's how we're going to create our scientific notation. We'll hit enter, and then that number will be displayed in scientific notation. So this is 5K, 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 and 1.67 K ohms of resistance. So our total voltage will be the same throughout all of the circuit, since voltage is the same in a parallel circuit. So we will just type in this value as data, and that will be 30 volts. And again, when you turn this in, I want you to put your 24 volts, but I want to show you how to make different voltages and how it will calculate for you. So, and voltage is the same. To make this the same, we're just going to type in equals, and we're going to have this cell. So this cell is going to equal this cell. So we don't have to change each individual cell. If we just change this cell, it will change all of them for us. So again, we're going to hit equals, and then this cell and enter, equals this cell and enter. And that will allow all these cells to change if we change this one cell. So that will keep all of our voltages the same so we can calculate each one of them correctly. So to find our total voltage here, to find our total current, it is just voltage divided by our resistance. So again, we'll make a formula that says our voltage is going to be divided by our resistance, and then we'll just hit enter, and then it will automatically do this for us. Our power is going to be our voltage times our current, so we'll hit voltage times our current, and then this will give us our total power. And now we can do each circuit here the same way. Just make this cell, this voltage divided by the resistance. Okay, I have completed my table. I just want to show you what it will look like as we change our values. So if we put in 2.2K, which is 2,200, if we put in our 3.3K, which is 3,300, and we put in our 5K, which would be 5,000, and then if we put in our total voltage of 24, then the box will fill our formulas for us. This one is just not being displayed. Our column is just a little too small, so we have to make our column a little bigger so it will display our numbers in there correctly. So that is how we're going to do our Excel file. And again, I want you to put your title across the top. I want you to center it. I just want this to be a parallel circuit. I want you to put some kind of border around it. You can click on this and make it easily a border around it, and we'll do the N. So you can put some kind of border around it, and it doesn't matter what color. I would just like for you to dress it up just a little bit. And then when you're finished, you go to File and you save this as Parallel Circuit Excel file and put it in a Submit on your Blackboard.